Okay, now let's talk about continuous again. But like, in your homework or textbook, maybe you can find a really simple and easy problem, okay? But I set up really complicated problem for like, the worst case, okay? So let's talk about this, okay? So to talk about this, like to try to make this function as continuous everywhere, we have taken only 2 points at x equal 2 and at x equal to 3, okay? So we're gonna talk about like 2 points separately, then we're gonna try to figure out which a and b value is working for those 2 points like at the same time, okay? Here we go. So let's start from at x equal to 2. Do you remember? To talk about continuity, you have to talk about like 3 steps, okay? The first one, you must have function value at this point. Second one, you have to have the limit at this point. And also like, your function value must be equal to your limit value, okay? So let's start from here, okay? Function value. Plug in 2 in there, okay? Which is f of 2. Well, since you have equal sign on 2 in the second equation, we can plug in 2 into the second one, okay? A 2 squared minus b 2 plus 3, okay? Which is equal to 4a minus 2b plus 3, okay? But this is function value, okay? And also, you can easily figure this out. It's not only function value, but this is right limit, okay? Okay. Then, what about left limit? X approach 2 from left-hand side with function, okay? Since this means x is less than 2, we're going to use first one, okay? It is equal to limit x goes to minus x squared minus 4 over x to minus 2, which is 0 over 0 form, indeterminate form. Then we're going to try to cancel out the 0 factor, okay? It is here, equal to limit x goes to minus and x minus 2, x plus 2 over x minus 2. Then as we expected before, then this 0 factor is gone. Then by plugging 2 in here, and we can easily find your left limit is 4, okay? So well, but keep that in mind. We are not going to evaluate this as continuous or not, okay? But we have to try to make it continuous everywhere, and also like this point as well, which means your function value, right limit, and left limit must be equal to each other, right? So then I can set up the first equation, okay? Which is 4a minus 2b plus 3 equal to 4. Let's say this is star equation, okay? We're going to use this one later, okay? So now let's move to at 3. Here we go. We will do the same thing, okay? So first you have to check the function value, f of 3. Do you have it? Yes, definitely. We can use third one, right? Plug in 3 into third equation because that is equal sign, okay? Which is 6 minus a plus b. Again, this is function value and also right-hand side limit. Is okay? So now, like to talk about number 2, we need to have left limit, which is limit x goes to 3 minus with a function, okay? So this means x is less than 3, then we have to use the second equation, right? Plug in 3, okay, let me rewrite this one. X goes to 3 minus with the second equation. Then we can just simply evaluate this one by plugging 3 in there. It is equal to a times 3 squared minus b 3 plus 3, which is 9a minus 3b plus 3, okay? Again, we have to make it continuous at this point, which means your function value, right limit and left limit must be equal to each other, okay? Here we go. So now I can say 6 minus a plus b must be equal to 9a minus 3b plus 3, okay? So let me move everything to the right-hand side and like number to the left-hand side, okay? Then this will be 6 minus 3, 3, and plus a, 10a, and minus 4b. Let's say this is double star equation. Okay? Now can you find it? Dun, dun, dun. Star and double star. We can set up the linear system. Is okay? Here we go. Let me come back to center, okay? Here we go. From star and double star system. Like this one, let me like subtract 3 on both sides. Then it is 4a minus 2b equal to 1. And the double star, 10a minus 4b equal to 3. Okay? So there are two ways, okay? We can do the like substitution method or elimination, okay? Since we use like substitution too much, let me try to show you how we can use the elimination, okay? So to do elimination, let me try to match like this b term, okay? To do so, I'm gonna multiply -2 for the first equation, okay? Then this will be -8a plus 4b equal to -2, okay? Just rewrite your second equation, don't do anything. And then add up. Then your a term will be 2a, and b term is gone, and right-hand side equal to 1. Then I can easily find my a must be equal to 1/2 by plugging back this one into here or here or here or here. Doesn't matter, okay? Anywhere, okay? Plugging 1/2 in there. It is, okay, your b is 1/2 as well, okay? What does that mean? As long as your a and b's are 1/2, then your piecewise defined function will be continuous at x equal 2 and x equal 3 as well. In other words, your function will be continuous everywhere.